Hello and welcome to this YouTube session. My name is Navid, and in this session we want to know lots of things about NumPy library. Before we start, don't forget to press subscribe button to receive several useful machine learning videos that I post regularly on my channel. Okay, let's start. Okay, so this is the Jupyter Notebook IDE. So if you don't have it or you want to be familiar with it, I have already described it in one of my videos. So go and check that out. To start working with NumPy, we need to first import the library. So let's do that by importing a library here. Let's say import NumPy as NP, and by just running this cell, I just imported NumPy as NP. Now I want to create my first array, and I want to name it A. So let's say A is NP.array, and parentheses, inside of the parentheses I should use two brackets. Don't worry, don't forget this procedure. So parentheses, two bracket, and inside of the first bracket I should mention my first row. So my first row, for example, I have two numbers, two random numbers, 2 or 3, for example, in my first row. And let's say I want another row as well in my A array. So let's say the next row is 5, 7, completely random numbers. I want to make another array as well. I want to name it B. So let's say B is equal to np.array, again, parentheses, bracket, bracket. And I want to have two rows and two columns again here in my B array. Let's say 4 or 4 and 5. And also another bracket, and I want to have 2 or 2 and 8. Okay, so now I have my two arrays, so I can just run this cell and go to the next cell. Just check if we want to check that A and B array that we just built with together. Let's say print A and print B. So we want to see what we created, and by running this, now we can see that this is our A. We have two rows and two columns, as you can see, and this next array is our B. We have again two rows and two columns for that. It's just like a matrix. So that's it. We created our arrays in a first step. And in the second step, we actually want to implement some of the main mathematical operators in these arrays. And let's start with multiplying. We have two options. If I say, for example, let's put the multiplying in another variable, name it C. So let's say C is equal to, if I say A star B, this is one option. And if I print it so I can see it and run this cell, now you can see the result is what? The result is actually coming and it's going and multiplying these two, each element by elements of arrays with together. For example, 2 multiplied by 4, so here we have 8. 3 multiplied by 5, so here we have 15, and so on. 5 by 2 and 7 by 8, and we have 56. So if we want to multiply these two arrays element by element, we should use a star. The other option is, for example, let's say I want to have C2, name it C2, and this time I want to say A. This time I'm using another operator, let's say another sign, let's say at sign B. So the previous time we use a star, now we use at sign. Now if I print my C2, you can see that, and if I run this cell, you can see that the numbers are different. So what happened here? This time, it actually consider arrays as matrix and multiply two arrays just like the way that we multiply two matrices with together. If you remember from the high school, if you want to, if you consider this matrix 1 and matrix 2, A and B, and the first row to the first column will be this element. So let's say 2 to 4, 3 to 2. So we have 8 and 6. So the summation is 14, and so on. For example, let's do another one to get this row to this column. So it would be 2 to 5 and 3 to 8. So 2 to 5 is 10, 3 to 8 is 24. So the summation will be 34. So that's it. That's exactly how we multiply two matrices with together. The next thing that we want to discuss with together is another way to multiplying. So instead of saying instead of using this star or this add sign sign, we can use another way. We can use the NumPy, some NumPy methods. For example, let's say I want to name this f, and f is equal to mp dot. Okay, I'm using the dot method. So, and inside of this, I'm using a and b as my two arrays that I want to use the dot method on them. And if I print f this time to see what's going on and run this, you can see that we have the same array that we had when we use the add sign. So with using this dot method, we actually are multiplying our two arrays in the same way that we multiply the matrix. So you can use the add sign, or you can use the dot method, same results as you can see. And also you can also use another method named multiply in order to do this instead of star. So let's say I want to name it E is equal to mp dot, let's say, multiply. And inside of the parentheses, I'm saying A and B. And if I print this, and run this cell, you can see that we have the same results as we had here that we're using stars. So this time it goes and multiply each element of these array A to the other elements of the array B. So first element, second element, second element, and so on. So we have the same result that we have when we used star. In order to have a summation of the two array or subtract two array together, we can simply use the operator and that we use for uh, summation and subtracting two numbers with together. It's very simple. You can say a minus b, or you can say a plus b, and you will have the results. And it's not very difficult, but the important thing that I want to show you is, let's go to the next number. So you can see that we can have the arrays. It shows the array for a minus b. Let's say I want to have the summation of the I want to have the summation of the all elements in the A array. So this is our A array, 2, 3, 5, 7. Imagine that you have a very big array and you want to have the summation of all elements with together to see what is the final result. To do that, we use a very simple method in NumPy, and let's say I want to name it H, for example, and this is np dot sum. Very easy. And inside of the parentheses, I should mention the name of the array. And if I print this to see what is the result, and you can see the result is 17. And if you just sum up these numbers, 2, 3, 5, 7, the final result is 17 as well. So this is when we want to sum up all the elements in our array. And if you want to subtract two array with together, let's say this time the h is equal to mp dot. This time instead of using this minus sign, we use the subtract. So let's say subtract, and inside of the parentheses, I'm using the two arrays that I want to subtract: the first array and the second array. And if this time I print the h and run the cell, you can see that it goes and subtracts a from b for me. The previous time, this is the results of the a plus b. So the results of the a minus b is something like this, or I can say, for example, the h is equal to a minus b very easily. And if I print the results again, we should have the same results. Yeah, you can see the same result. Before going to the part that we understand how to divide two arrays, let's talk about broadcasting. What is broadcasting? So let's say you want to make an array that is the combination of another array. So let's say you want to name it, for example, BC. And this is equal to your B array that you just created here, this one, and summation of a number. So you may say, okay, the result will be an error, but let's check it out. Let's print the EC to see if the Python give us an error or it will give us a number. By selecting and running this cell, you can see that the result is not an error, and it's an array. So what happened here? This is what we call broadcasting. And the Python actually expand this number that you give it to it as the same size of this array B, and then do the calculation. For example, this is what Python do. It says, okay, the BC is equal to B that you already created plus uh, plus not the number 3, but an array with the same size of B. What is the same size of B? We have two, if you remember, we had 2 rows and 2 columns. So let's say we want to make an array. So the np.array, and inside of the parentheses, we have 2 brackets. This time we have 3 and also 3. Okay, so this is actually Python is doing. It actually creates another array with the same size of B with this number that it just duplicate the number to the same size of B, and then it actually add this array to the B, and this is the result. So this is what we call broadcasting. So this is not just for numbers. If you, for example, let's go for another example. Let's say I want to create another array and name it n, for example. Okay, we're using all the alphabets. So the n is equal to np dot array. I want to make another array, parentheses, brackets, and I want to have, for example, 2 rows and 3 columns this time. Say 1, 2, 3, and again, comma, and another bracket, and I want to say 3, 4, 3, 5, 7, for example, something like that. So this is another one, and let's say I want to have another variable named m, another array named m, and I want it to be mp that's array, this time not the same size as n. So let's create another array with just 1 row and 3 columns. So let's say bracket, inside of the bracket we should say okay, this time we need just a one, let's say 4, 6, 8, something like that, some random numbers. Okay, so this time the m is actually 1 row and 3 columns, and the n is actually 2 rows and 3 columns. So you can see that the size of the array n is completely different from the size of array m. So if you tell Python to just actually sum up this m and n with together and put it into another variable, name it, for example, mn is equal to m plus n, and if you print the mn at the end, you imagine that we should maybe get an error because the size of the n array is different from the m, but actually what will happen, let's see what is the result. So the result is not an error. Again, it's an array with the same size with n. So what happened here is exactly what happened in the previous cell that we did it for BC. BC is equal to B plus 3. So as I told you, it just changed the 3 as a number. It changed it to an array with the same size in B, 2 columns and 2 rows. what happened here is exactly the same. We have n with 2 rows and 3 columns, m with 1 row and 3 columns. What will happen here is the broadcasting that Python actually expand this m array from the 2 rows to 2 rows and from the 1 rows and 3 columns to 2 rows and 3 columns. So this is what Python do. It's actually see the m as something like this: array and bracket, let's say this time 4, 6, 8, and it makes another row immediately, and again copy the first row: 4, 6, 8. Okay, so if I just copy the n again, so let's see if the results are same. So let's say this time the m is like this, the n is like this, and if I just want to have the mn, so I should have the same results. I just want to show you that how Python broadcasts these two arrays. So let's say if I run this cell, you can see that we have the same result. So this is what happened. Actually, Python broadcast this array from 1 row to 2 row, but just copy this row to the second row to make it as the same size that n is, and then add the n to the m, so and create the mn. So that's very easy. So remember that if the size of the two arrays that you are doing the subtraction or adding up two arrays together is not the same size, Python actually changed the size of the one to the same size as the previous one, and then add them up. So this is what we call broadcasting. Now, let's say, for example, we want to divide an array by a number. So it's very easy without even creating another array. Let's say, for example, d is equal to np dot divide. So we want to use the divide method of the NumPy, divide. And inside the parentheses, you should mention the array that you want to divide a number by. So let's say the array is a list like this: 12, 14, 16, something like that, or 17. And let's say after the comma, the number that you want to actually make the divide the array by that number will be, for example, 6, let's say something, or 7, because we want a float number. So let's say if I print the d at the end, I want to see the results and run. You can see that the division will happen, and this is for it actually goes and divide each element of this array by this number that you specified for it. For example, 12 divided by 7 is 1.7, 14 divided by 7 is 2, and 17 divided by 7 is 2.4. Let's say you don't want the float number and you want all the numbers to be integer like the second one. So the way to do that is not very difficult. We should just use another method of NumPy. Let's say this time d is equal to np dot, this time instead of divide, I'm using the floor underscore divide. So let's say floor underscore divide. And again, I can just copy and paste this line, this section here. And again, if I just print the result and run the cell, you can see that this time we don't have the float numbers. It just it actually floor the round the numbers, the results to the lower part. So it's the 1.7 is 1, 2 is 2, and 2.4 is 2. You can see that we just rounded it so we can have the integer numbers instead of the float numbers. This is one way. And there are lots of things that you can do with NumPy. Lots of interesting things, lots of mathematical operations. These are the 4 main mathematical operators that we discussed. You can do other things with NumPy. For example, I just want to mention one of them here. That is, let's say you want to use to SQRT numbers. You want to have a radical of numbers. So let's say the SQ is equal to NP dot. We use the method name SQRT very easily, and inside of the parentheses, you should mention the number or array that you want to implement this method SQRT on it. For example, let's say 10, and if I just print this SQ for myself and run this cell, you can see that the results will reappear. So there are lots of mathematical functions that you can use from NumPy, and they're very interesting. So I just use one of them, show you one of them here, SQRT of an array or a number. So this is it. The next thing that we want to discuss is actually, and it's very important, is actually generating random arrays, because it's very important for us. But before that, before going to that part, I want to show you how to generate 0 arrays and 1 arrays, because sometimes in modeling, data scientists need some array that all the elements are 0 or all of them are 1. So in order to do that with NumPy, it's very, very easy. So let's say, for example, the 0 is something like this. This is our 0 array. So we use np dot and the method name zeros. And inside of the parentheses, it is important that you should mention actually the size of the array. So we have 2 parentheses. Inside of the parentheses, you should mention the size of the zeros array that you want to create. For example, let's say I want to have a size of 5 rows and 7 columns. Okay, so if I just print the Z, let's say the name is Z, it's better. So I want to print this. Okay, as you can see now, I have an array with 5 rows and 7 columns here, and also I can do the very same thing I can just copy and paste it to the next cell. So I can say I want to have a 1 instead of zeros. So instead of zeros, you should just say ones. And if I select and run this cell, you can see that I have this time an array with 5 rows and 7 columns, 7 features that and name it Z, and all of the elements instead of 0 this time is 1. Now let's go back to the part that we want to generate random arrays. So let's say we start from something simple. Let's say someone asks you, okay, I want a random number, just a number between 0 and 1. So let's say this random number is named ND, and this is equal to np dot. We use a method named random.rand. So let's say random.rand and an empty parenthesis. So if I just run this, and you don't need to put it in a variable. So let's say this, I want the result of this one. So each time you press run, you can have different random number between 0 and 1. So with this one, with this line, you actually get each time a random number between 0 and 1. But let's make it a little bit complicated. This time I want an array. I don't want a number. I want an array. I want to specify the lower and higher bounds, and I know the size of my array. For example, let's make one, and this time name it ND is equal to let's say this time I want to use np that's random. Instead of random.rand, I use random.rand int. So let's say random.rand int, because I want integer numbers. So, and this time inside of the parentheses, the first thing that you should define if you just forget what you should define inside of parentheses, you should just press Shift and Tab with together in your keyboards, and you can see that the first thing that you should define is the low side of your array. The second part is the high side of your array, and the third part is the size of your array. And also you can define the type that the default is integer. So inside, so let's start. For example, I want my array to be between 10 and 80, something like that. And I want the size of it to be, for example, I want 3 rows and 4 columns, something like that. And if I just print my ND to see inside of the ND and run it, you can see that a random array between 10 and 80 with the size of 3 rows and 4 columns, 4 features, 4 variables, anything that you call it, is created for me here. So it's very easy, just play with it. You can say, for example, from this time from 20 to 100. And also the size this time I want to be 4 and 5, 4 rows and 5 columns. So this time if I want it, you can see that I have an array with 4 rows and 5 columns, and this time all the numbers in the arrays are between 20 and 100. So that's it for generating an array. And the important thing here is I just created this array to show you something. For example, you have an array like this and you want to filter out some of the numbers in this array. Imagine that you have an array of thousands of numbers and you want to filter some of them out. And that's a difficult thing, but you can do it with just two line of code with NumPy. So it's very easy with NumPy. Just we should use a method named logical. And let's say, for example, I want to filter out. Let's say I want to filter ND, okay? And I'm using a method in NumPy named logical underscore. So we have different logic here. If I will show you how. For example, let's say and inside of the parentheses, I'm saying, okay, the ND is more than 30, or this time, let's say more than 40. And the other thing that I want to specify is ND more than 40 and less than, let's say 60, okay? So actually I want to filter out these numbers, 48, for example, 37, 45, 40, these are all, not 40, 49, more than 40 and less than 60. I want to filter them out and see what are these numbers. And if I run this one, and if I check the results right now, underscore ND, oops, I got an error here. So it's saying that, okay, sorry, that. Now if I do this, so you can see that the result is actually it is giving you an array exactly with the same size of your ND, but this time it is giving you true and false, okay? With this logic that you defined, logical AND, it means that the ND is more than 40 and the ND is the numbers less than 60. So you want both of these terms to be true, and that's why you use AND. And here, this is the result. You can see that, for example, 96 is false because it's not less than 60. It's more than 40, but it's not less than 60, and it should have both of them. So 56 is exactly true because it is between 40 and 60, and so on. But I don't want this array. I want to filter them out. I want to see the numbers that are true, for example. So to filter them out, it's very easy. Just say, for example, f underscore, let's say f and d is equal to, this time I use the ND that I created, and inside of the brackets, I'm saying I want to implement this filter ND. So I just copy it here and paste it here. So that's it. If I just now print the F and D for myself, now you can see that we have the list of the numbers, the elements of this array that are more than 40 and less than 60. Okay, these are the numbers 56, 48, 45, 49, and so on. So this is very, very helpful when you are dealing with very big arrays and you want to filter out some of the numbers. For example, you want to know that if you have numbers uh, between this and this. And also you can use other logic as well. For example, let's say if I just copy this line and put it here. So I want to change this and to or this time, okay? When you're saying or, it means that even one of them is okay. So let's say this time I want to say the Andes, for example, less than 30. For example, this 26 is less than 30, okay? And this time is or, this is not and. And again, and the less than 60, something like that. So this time is actually even one of them, even one of these terms, if this is true, for example, and the element less than 30, it goes as a true, so it copies in the filtering that we ask from the NumPy. So let's do that. Let's say now I want to print it for me. So let's just copy and paste this here. If I just say, you can see that this time this one is a little bit different from this one. And if I just filter them out, just like what I did here in the filtering section, okay, and just run it again, you can see this time we have a bigger rate of numbers because this time we are not saying ND less than 30 and ND less than 60. We are saying even one of these are true, it goes to this array. And the less than 30, it goes here, and the less than 60, it goes here because we are using the or logic, not and logic. So these are all the logics that you want to use, and or and other logics. You can just play around with the other logics as well. I just wanted to show you how you can filter out some of the elements for yourself from the big arrays that you have, and play around with that with the logical method of NumPy. I hope you liked the video, and if you want to learn more with much more details and understand the concepts better, you can check my Udemy course. You can find the link in the comment section and email me for discount coupon if you need one.